Welcome to video 3. In the first video, we went over this first rule, what you do to one side, you do to the other. In the second video, we went over the second rule, which was to always use inverse operations. So now we're going to put these two rules into action with one of our hanger mobiles that you saw in the very beginning in video 1. So here we have this hanger diagram that we've also already seen. The left side has 15, the right side has y, y, and y. I also put this information into this table right here to better see my information. So the items on the left were 15, the items on the right were here, y plus y plus y. If I wanted to simplify this, 15 would stay the same, but y plus y plus y is also known as 3y. So because these two sides are both balanced, that means they're equal. So the left side is going to be equal to the right. So I could replace everything with 15 equals 3y. So let's look at the first rule. We have using inverse operations. So if I have 3 times y, instead of multiplying, I'm going to do the inverse of multiply. I'm going to divide. So divide both sides by 3. So I'm going to divide 3y by 3 is 1y. What you do to one side, you do to the other. That's our second rule. So because I divided 3 by here, I'm going to divide 3 on the left side. So 15 divided by 3 is 5. And that should give you 5 equals 1y. Or you could also write it as 5 equals y because there's always an invisible 1 as our coefficient right here. You could also write it as y equals 5 with the variable on the left. Just depends on what you prefer. So that's our first example. Let's look at some examples from the textbook. So if you want to follow along, you can. These are already worked out problems, so just use this to check your work or pause the video. Our first problem was y plus 6 equals 9. The first rule was use inverse operations. So if I'm adding 6, I'm going to subtract 6. The second rule is what you do to one side, you do to the other. So because I subtract 6 here, do it to the other side, and you should get y equals 3. Example B gave us x plus 3 equals 1. This is a little bit harder because you can't find a number as easily that you add 3 to get 1 because 1 is smaller. So you're going to have to subtract 3. That's your inverse operation. Subtract 3 on the other side to fulfill the second rule. And if you have your number line, you may use it. If not, I went ahead and drew one. 1 minus 3 is going to give me 1, 2, 3, negative 2. So x equals negative 2. Make sure when you're writing your solution, you don't just put negative 2 or you don't just put 3. Make sure you include the variable equals the value. Example C. Negative 3 equals a plus 4. I have positive 4, so inverse would be negative 4. What you do to one side, you do to the other. Negative 3 minus 4, when you subtract, it means you go downwards. Negative 3 minus 4 is 1, 2, 3, 4, and you end up at negative 7. So negative 7 equals a. I personally like the variable on the left side, so I put a equals to negative 7. On the next page, we have 439. And we are subtracting. So example E says y minus 3 equals 4. Because I'm subtracting, I'm going to do the inverse, which is addition. What you do to one side, you do to the other. Negative 3 plus 3 is 0. 4 plus 3 is 7. So that gives me y equals 7. F. R minus 4 equals negative 2. Inverse is add. Add 4 to both sides. Negative 2 plus 4, that means you move upwards. So negative 2 plus 4 is 1, 2, 3, 4. It goes to positive 2.